Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward.
All right, welcome everyone. It's a beautiful summer day in Crested Butte, and we are back after a bit of a hiatus.
That is correct.
We, I don't know, it was summertime, and we, had summer things happening. Bruce is out in California, and I don't know, I've been everywhere, Seattle and places.
I wanted to start by saying that we have figured out when the developer retreat is going to be
here in Crested Butte, Colorado.
And that is August 28th through September 1st. And this is very low key.
Come up and hang out with nerds.
We hang out. Often discussions happen. So,
well, I think in the remote working world, especially, people do enjoy the times when they can come together with other peers and code togetger. So,
yes,
so that's all that it is. It's nothing too
right. And to find out more about it, you go to the WinterTech Forum Slack channel, and then you can ask questions there. But basically, we don't charge anything for it. It's just come ready to camp or stay in a motel or something like that. It's possible to camp in my side yard.
Yeah.
So or the porch.
That.
So yeah, people have done that. So
great.
Anyway, so that's August 28th through September 1st.
Fantastic.
All
right. Well, today, super excited to have Venkat Subramaniam with us. And Venkat, man, we go back a long way, so it's fun to have you on. And so, welcome. Thanks for joining us.
Thanks to James and Bruce. It's been a long time, meeting at conferences, and it's an absolute delight to meet on this podcast and talk about techie stuff. So thanks for having me.
Yeah, looking forward to it. So we've got this exciting thing happening thanks to Venkat in about 6 weeks, which is Venkat, for some reason, was like, I'm going to do a conference. And he decided he was going to do it in May 2020, which turned out to be a really bad idea.
Choice.
I don't know why he didn't foresee that one coming. So it's now the actual first instance, I think, of the Dev to Next conference is coming up in October, like first week of October. And Bruce and our other co-author, Bill, and I will be doing a presentation there on our new book and the content for that called Effect-Oriented Programming.
That's right.
So it's going to be kind of the debut of the book and the content from the book. So yeah, super excited about Dev to Next. I don't know.
You're making another presentation.
I do have another presentation on. It's called "What the Functional Programming."
Nice.
And that one is with Hadi Harari. So
yes.
Yeah. So looking forward to that one as well. So Venkat, thank you for putting together that conference. Can't wait for it. Tell us a little more about the conference. Why did you decide to do this? What else
possessed you?
What else is going on there?
Well, so I think the key is, the three of us, as we know it, we travel around the world. We meet some amazing, developers who are fantastic speakers. And what I realized is, while we have this amazing wisdom around the world, we don't get to enjoy that as much here in Colorado with such a diverse set of speakers. So I asked myself, what if we turn this into a conference where it's an open enrollment, where people can submit talks, they get evaluated for merit. And so I had the privilege of an amazing program committee of very well-known speakers who went very thorough in evaluating. We received 430 proposals for well over 100 sessions. I couldn't be happier with the way the program shaped up. So we got some strong emphasis on architecture and DevOps and current trends, where current trends obviously means a little bit of AI into it as well. But again, such a wealth of and breadth of topics, anywhere from functional programming to observability on one hand, to architectural patterns and constraints and name it. So I couldn't be happier. But it truly is a program that I wanted to put together. But I did not realize how smoothly it would evolve, all thanks to the program committee that worked so hard. So I'm super excited about it. And we got about, as you said, 6 weeks out. And as you can imagine, we are putting together a lot of those final preparations, ordering the swags and getting the meals ready in the hotel and various other logistics. So it's going to be a very sleepless 6 weeks for me, I think.
Yeah.
But it's going to be
You've got a
worth it
lot of work to do
when
in the
this
next
happens.
6 weeks. And
You wrote did you write the code for the automation for the
the whole
conference?
Well, it
website.
depends on whether you say it's good or bad. No, I did. It's homegrown, so everything I wrote from the scratch. That's one of the things I really wanted to do, is to build this experience into it. So all the submission of the talks and evaluations, what you probably don't see from the other side is the entire communication of the program committee happened on the website through messaging. One of the things I really thanks for that question, because this goes back to some fundamentals I practice. I think email is the worst way to communicate about things you want to remember. 6 months from now, you're like, what was that email again? Where did that go? So the very first step I took was to get rid of email communication or any other form of communication like Slack, what have you. So all the communication happens through the site. That way you can go click on it in one place and you can look at the entire conversation that you had with the speakers and the program committee and the starting from proposals to arranging for travel and hotel. Everything is done through it. It's something I took pride in building from the ground up.
Well, and one thing I've always appreciated about you is that you aren't just a teacher. You're an amazing teacher. But I think part of the reason why you're an amazing teacher is because you're actually building things and writing code. So I love that you kind of like are able to blend those two together in a way. It's like you built your own conference site and you wrote all the code for that. And I'm sure that that helps you stay current with trends, try new things, learn new things, and then you can take those learnings out to the developers that you're then educating. So it's a fun way to do it.
Was that all in Java, I suppose?
No, but we will take that offline and talk about it.
Oh, no.
He wrote it in JavaScript. He secretly loves
everything,
JavaScript.
not even TypeScript.
But to James' point, there's a lot of learning that happened in that. One of the things I truly, I don't say this as a lip service. I once tweeted saying that I do automated testing not because I have a lot of time. It is because I don't. And in all honesty, the entire application was developed ground up test driven development. And I cannot tell you how many times that saved my neck and how many times it pointed me to errors well before I would go into production. I write the code and I get a feedback immediately. Especially if honestly, if you could call somebody a bad name, they forgive you after a while. You mess with their money, they're never going to be polite with you again. I'm obviously dealing with finance in here, charging people for various things, and I want to make sure that they are done correctly. We cannot have any lapse in accounting. We cannot have lapse in saying, "Oops, you registered, but we cannot find it." So a lot of that code was automated and tested, and so that gave me a lot of confidence as well in knowing. And again, to your point, is to learn about CI/CD entirely to make it happen. I spent the entire weekend of Thanksgiving. You can ask me, where were you? I was in Greece, and you could say, wow, Greece. Yeah, I spent 3 days working on putting the CI/CD pipeline into place for this. It was frustrating because you got to make sure everything is working. But the fact that it is working, ever since then, I've deployed the application thousands of times, every step of the way, because this is the first time the conference is going to come to life. I'm adding features continuously every other day, every 2 days, and fixing, making improvements or enhancements. And the minute you deploy it, you're like, oh, this could be so much better. And to be able to just do a git push and then it come out on the other side and be deployed is amazing. And so I'm giving a talk later early next week on 12 effective things you need to do for CI/CD. Well, a lot of lessons learned from that and other experiences as well is something that it's nice to be able to put that into practice and learn from that experience, but also to come out and show that yeah, it is frustrating. It is a journey that's going to take your time, but the time you spend on it is an investment, not an expense, because you regain on that time so rapidly as you move forward with the application. So if it's any application that's going to survive for more than a few months, I think the technical rigor we put into it is very well worth, if we care about our time. And I think most of us do, because time is the most valuable resource we all have. And if I'm sitting there and fighting with a piece of code for the next 30 minutes and not realizing when it's broken, well, that's a huge time saving for immediate feedback loops. So a lot of learning went into it, and it's kind of
And it's
the
probably no coincidence that you've been presenting about TDD recently in conferences. Maybe,
for a while, actually. and,
yeah.
and and that's kind of what I was saying is, to take what you've been doing and apply it, but in the process of applying it, with a greater understanding and deeper understanding as well, and then to come back out and start talking about it again, is so one of the things I've been firmly believing for the past about 30 plus years I've been teaching and programming is, I cannot imagine being a teacher without programming. And to a great extent, I would even say I cannot imagine being a programmer without teaching as well.
Huh.
And this is where I think the
There's a
mentorship
flywheel
comes
there.
really well, right? Anybody who is programming, take somebody as a mentor, and as a mentee, and mentor them and start teaching them. You really begin to learn areas where you don't know enough, and you want to go back and learn a lot more. So I think that's a really nice synergic steps to have. You don't have to be teaching formally in a university or in a speaking in a conference, but just taking one or two programmers and walking them through a concept you understand immediately, I think, brings to surface the gaps that you have in your understanding. And especially when they ask questions, that's what I love about speaking is the questions. The worst classes are when people listen and walk away, but the best ones are the ones where they're asking questions and you're like, I got to think about that,
Yeah.
right? And I'm taking notes about things I need to go back and dig a little deeper. That's when you
So
turn
fun.
from being a teacher to a student for a few minutes. And to me, that's the most enlightening part of teaching, is that moment when you can be humble enough to become the student momentarily, to say, oh, I've got more things to learn right now. And in a way, I would argue, right, if we don't have a need to learn more, I think we are done. So that's what really excites me about being in this field is, you are a student for life. So
Yeah.
that's great to be in that situation.
So speaking of teaching, you said you were going to teach us about bundles or something. What is it? I've forgotten what it is.
some
Yeah.
new
So
exciting thing.
I was so Victor Klang has been working on an interesting feature in Java called the gatherers.
Gather.
And gatherers is, when I heard about it, uh, I'll be absolutely honest about this. This is again the part of me, where I feel humbled, because I love being proven wrong. Because when you're proven wrong, it excites you to know that there's more things to learn, more things to expand.
And I will
So
note that anything that Victor Kling creates, there is always more to learn because that
there
guy
you
is
go. I
genius.
couldn't agree more.
He is genius.
He
And
is
so
amazing.
just
He's
as some
amazing.
backstory, I used to work with Victor when we were both at TypeSafe, now Lightbend, and he created the Scala Future library, which I think you probably used very heavily, and Bruce probably has some exposure to. But just a brilliant, API, and so yeah, he's done so many amazing things over the years. And so just recently he joined. It feels like recently he joined Oracle and is now working on the Java JVM team there. So excited to see what Victor is creating next, and I'm sure it'll take me a long time to learn it, but with your help, less time.
Well, so my aha moment was, so one of the questions that I've heard in the past is, you're using filter, map, reduce, and all these other functions, like take, while, limit, and the question is, what if we need something that doesn't fit into any of those? And from the functional programming point of view, you could say, filters and map and reduce, And functions like that are the nuts and bolts of the functional pipeline. So you often build your functional pipeline with those functions. And Victor comes along and says, hold my drink. I'm going to show you how you can create custom steps in the functional pipeline. So the idea is, let's say you have a problem at hand and you want to implement it in a functional pipeline. So the obvious thing we all do is to ask the question, I've got these, kind of like having these Lego blocks, right? Yeah, I've got this little filter block and I have this map block and I have this, limit block and take while block. How do I put these together to solve the problem that I
Transform
have
some
at
data
my hand?
structure. Yeah.
And so you're basically constructing the pipeline with the tools given to you. What gatherers allows you to do is to insert a custom step in the pipeline. And it could be before the filter or after, could be before the map or after. It could be just about anywhere, but it's an intermediate operation, not a terminal operation. So from the stream as a beginning point, to a reduce as an endpoint or a for each as an endpoint, meaning the source of the stream to the terminal operation. Anywhere in between, you can insert a custom, literally you can call dot gather on that particular pipeline. And the
And
minute you
so,
call,
question,
yep,
if
yep,
if you wanted it to be at the end, you said it could not be a terminal operation?
correct. So it's
Okay,
not a
so you could,
terminal
but you
operation.
could just attach something after it if you wanted to
Yes,
save
that's
it
right.
as
That's
one.
right.
Okay.
So it's required to be an intermediate
Mhm.
operation. In a way, you can say that it gives you the opportunity to do intermediate, what otherwise would have been a terminal operation. Let me give you an example of that. So take the example, if you will, of the for each ordered. Well, for each ordered gives you its terminal operation. It gives you an ability to, as an example, print out the elements, but in the ordered sequence they appear in the source of a stream. So even if you do a parallel execution, you're going to get them in the order in which they appear in the list, if you will. For each, on the other hand, which is also a terminal operation, will do the same printing as an example, but it would not impose the ordering. So as just as an example, you have two terminal operations. The for each, which is whatever the order it is not maintained, whereas for each order maintains the ordering. Now, look at the peak function. The peak function is an intermediate function in the pipeline. What peak allows you to do, as the name kind of alludes to, is to take a peek at the data as it flows through. So you can use it for debugging. You can look at to take a peek at, print out the value. So if you're in a sequential stream, as the data flows through, the peak can display that along the way. Well, as it turns out, there is no peak ordered. So if you were to convert this into a parallel stream, you have no control over what peak displays you. So the order is going to be jumbled up based on the sequence in which the thread is executing. It's non-deterministic. So the question really is, what if I want a peak ordered, just as an example? Well, you don't have a way to write a peak ordered in Java until Java 22. And gatherer says, well, if you really want a peak ordered, go for it. Just call a dot gather and implement a little gatherer interface that would grab the data and display it. And it's up to you to know how you configure the gatherer. So a gatherer can be configured in two different, axes, if you will. So to use the word, on x-axis, you can configure it as a sequential or parallel. So you can tell whether the gatherer, irrespective of where it's running, sequential or parallel, should run things in parallel in an opportunity to run parallel, or to constrain it to run sequentially even when executed in parallel, because you want to maintain that sequential ordering. So for a peak with in ordered, I would obviously run that in a parallel stream, but I will impose the ordering of sequential execution rather than parallel execution because I want to have the ordering. On the y-axis, you can tell whether a gatherer should be stateless or stateful. A stateless is I have no need to carry the data between processing of elements. Every single element is processed independent of each other. A stateful gatherer says, I processed element one, but the partial result of that need to be carried to element two's processing and the partial result of that. So in a way, think of a stateful gatherer as the facility of a reduce operation, which is terminal, but comes into an intermediate operation. So things like scan, Scala has scan function, as you know. Java doesn't have a scan function. Well, now it does because a gatherer has a utility function called scan that allows you to scan the elements as they process, so you can emit the elements as you are reducing them, but also continue to accumulate the results in the reduce as an intermediate operation. So it gives you that power of sequential versus parallel on one hand and stateful versus stateless on the other hand. So you can create a stateless sequential versus stateful sequential, or a stateless parallel versus stateful parallel as well. So it gives you that four different flexibilities. I do have to say that this is a pretty advanced concept. Implementing that is quite an effort. But once we understand the concepts, it makes it easier to get through that implementation detail.
It actually sounds a lot like the effect stuff we've been working with. So I get what you're talking about, but I'm wondering how, like, do you have to change your data? Do you have to change your functions? How does it, how does it keep track of like whether something is ordered or not ordered?
And this is all
Right.
just on the Stream API, right?
Yes, that's right.
Okay, so it
So,
has to
so
be on the Stream API.
it preserves the encountered order. So one of the beautiful things about Stream is, as you know, a stream doesn't impose ordering by itself. So if you have a set and you don't do anything that affects ordering, then there's no ordering because sets are unordered. So that would be an unordered collection. If you have a list, on the other hand, the ordering is imposed by the list. So the order in which you encounter the elements is the order enforced by the list. On the other hand, let's say you had a set, but you injected a sort in between. Well, the sort is bringing the ordering now. So any step before the sort has no ordering, but any step after the sort has an encountered ordering. So the gatherer, if it is sequential, simply follows the encountered order. So if your collection was a set, well, it doesn't have any ordering to follow, but it just follows along whatever sequence in which the elements are given at that point. But if it was a list, that's going to be the order that's imposed on it.
So I'm seeing some similarities between this and Akka Streams, which I'm sure is not too much of a coincidence given Victor's past life, because Akka Streams had some similar capabilities. And I built a few things with Akka Streams, and although I'm not a huge fan of the actor model, Akka Streams was actually a really nice API for dealing with streaming data and the writing essentially gatherers and doing those intermediate things on streams and connecting streams to streams and all that kind of stuff. So,
but I want to know how it does this. Is it a macro thing? Is it like?
Sounds like it's going into the JVM. It's part of the standard library.
Yeah. So essentially, so let's expand on that a little bit. So you have a gather function. So a gather function is no different in the way it looks than a filter and a map. So just like filter takes a predicate, a map takes a function, a gather takes a function as well. Let's just say for a minute. But except that function, in the case of a filter, it's a predicate. In the case of a map, it's the uppercase F function. In the case of gather, it's an implementation of a functional interface called the gatherer. So the gatherer is an interface. So the gather method simply says, if you call gather, I will take the data and hand it over to the implementation, which is the gatherer. So what the gatherer does is something really cool. The gatherer says, I have a handle on the downstream. So the gatherer interface gives you literally a reference to the downstream. So let's say right after the gather, you put a map. So you have a handle to the map, so to say, because that's the next stage in the downstream in the pipeline. So, and what you do is you're given an element and you make a decision what to do with the element. Either you want to transform it, do some manipulations with it, and then you decide whether you want to send it downstream or not. Maybe you decide not to send it downstream for whatever reason. You don't have to push it down. For example, a filter is a great example of that. A filter decides whether to push the data downstream or not. If the predicate is true, it pushes it downstream. If predicate is false, it doesn't push it downstream. Same way your gatherer implementation says, I'm going to decide whether to push this downstream or not. Then the next interesting part is when you call a push on the downstream, it's not a command, it's a request. Maybe you can call it as, could you please push this? And the downstream decides whether it really wants to push or not push. And because the downstream itself may have logic to decide whether it should continue operating with it or reject it. But then the downstreams, the push method returns a Boolean true or a false. The true means, thank you for sending this, but I'm okay for you to send me more data. I'm open. Or a false means, don't bother talking to me anymore because I'm shutting down the stream. So for example, if you were to call a limit or a take while, in the case of a limit, you have exhausted the number of elements that can go through, or in a take while, you've reached the predicate being false, you're not going to push any more elements downstream. So a limit or a take while as a stage in the downstream would return a false to you if it has, so to say, reached its capacity. So when the downstream returns a false, your gatherer in turn decides to send a false to upstream. So your function kind of communicates both ways. In that regard, James, this is kind of like what you said earlier, but it reminds me of the reactive stream API, because we do this quite a bit in reactive stream API as well. So
Victor was
you have
also one of the architects of reactive streams.
Bingo. And I'm going to tie this back to a comment later, but I'll come back to that after we finish this discussion. But I'm parking that for a little bit later. But so to say, you have two hands, one hand on the upstream and one hand on the downstream. So you do your work, you push it downstream, listen to what the downstream tells you, or you make your own decision, one or the other, and then you push that back to the upstream to say, hey, upstream, I'm okay with you sending more data, or don't bother sending me anymore. So that is
this
the
is how you
guts
would
of the
implement back pressure on top of the Stream API with a gather.
Right. So
There
I'm
you go.
imagining that maybe what's happening is that in order to make all this work, that at the JVM level, there's some rewriting of the function inputs and outputs so that the functions can actually fit together and pass this extra information or something. Do you
I
know?
would I would argue to your point, Bruce, that's already happening, because in the Stream API, the intermediate functions are fused together already. This is even before the gatherer. In a way, I would argue the genius of the implementation of the Stream API really makes this complex operations even feasible. So if you were to, as an example, say stream, let's say filter map, I call 4 functions. Well, the filter map literally gets fused into one function under the hood already at the bytecode level. So that's why, more trivially, if you think about it, if you just take a stream and call filter, and if you look at the return type, it's a stream. But then you can save that into a variable, not suggesting ever to do this, but you can save that into a variable. Then you can call a map on it, and that returns another stream, on which you can again call a filter, which returns another stream. So every time you call a function, it so to say is gathering all those steps into, or rather fusing those steps into one intermediate step.
So
And
you're saying the Stream API already does this
does
before it
that.
gathers. Okay.
That's right.
So it's
That's right.
almost, I mean, I hate to say it, but basically the Stream object is a monad, right?
I don't know if gather.
Well, I mean, no, in
just
streams.
Just the stream as it is today.
Because if
I would say
if
yes.
everything is a stream,
that
sounds like the same kind of thing that we see.
Maybe Venkat knows. I don't think it has a flat map that I would consider to be
I see.
monadic.
It does have a flat map too, though, right? The stream does
have a flat map, but I think its flat map interface is not exactly monadic.
Anyway, the concept is there. The idea that you're saying, oh, we'll pass the same thing everywhere, and then if we want to put extra information in that, we put it in that thing. In this case, it's the stream. So Victor just piggybacked on the existing stream system.
Yeah.
Yes, but it still required an enormous amount of effort to even conceptualize this. But I would say it's an act of two things, right? One is the fact that the Stream API literally lends itself to make this happen is pretty amazing. And the fact that he was able to leverage on that and create something that gives that capability is as amazing to me in terms of that. But going back to your comment on monads, my fundamental reasoning about monads is this. Here's how I define monads for my own understanding. I say monads give you an ordering in a world where otherwise there is no imposed ordering. That's the way I see it, right? So you can apply referential transparencies and you can move things around, which is fantastic, but there are times you shouldn't. And you really need to impose an ordering. So that's what I think about it as a monadic sequence often as you are imposing an ordering in a world where otherwise there is probably no ordering. And in that sense, you could argue the whole idea of functional pipelining is a monadic operation in that sense. And so it gives you that ability to say, do what you want to do, but ensure that the sequence is maintained as a pipeline of functions that execute in that order. Because if you jumble them up, you're going to have trouble with the logic, so that ordering becomes important.
Okay. I think of it as a way to connect functions and pass the extra necessary information, like error things in the type. So anyway.
Sequential application.
Yes. So it sounds like this is something that will do at least a lot of the things that we talk about with effect systems. I don't know if it does everything. How does it handle errors? Does it include the errors in the package?
It doesn't. So errors are still orthogonal to this. The Java Stream functional pipeline doesn't deal with errors, and so if you were to bring errors into this, it's going to get as messy or more messy than it has been before. So it doesn't really handle the errors at all.
So it throws exceptions.
You can throw exceptions, but the effect of throwing exceptions in that regard is going to be as I don't know, should I say catastrophic as throwing exceptions anywhere else in the stream. So I would say the effects probably are a better way to handle that mess. Which kind of takes us into a completely different issue. I firmly believe that programming with exceptions in functional programming is an awful thing to do. I often say that exception handling and functional programming are mutually exclusive, and anytime you try to mess with them together is a terrible idea. The code becomes not cohesive. You lose the fundamental beauty of conciseness and expressiveness of the code as well. So in all seriousness, I would say I would still rely on effects to probably find a way out of that rather than trying to mess with exceptions in functional programming. I think trying to continue to bring in exceptions into functional programming is a hope that programmers should learn to walk away from.
It's interesting because you've done quite a bit of Scala, you've done Kotlin, you've done Java, and so you've seen kind of the spectrum of how where people end up on the error handling thing. And it's interesting because Kotlin has in the middle between Scala and Java, it's like, yeah, you should use exceptions. But then people are like, but Kotlin, you're kind of functional and exceptions don't make sense here. And I think they're being kind of like, there's this tension for the Kotlin folks to like figure out what their relationship to exceptions is, because they also want to be able to have good interop with Java. And on the other side, the Scala side, they're like, yeah, exceptions are side effects and you need to manage those and they need to compose and all those kinds of things. And the Java side is still very much in the exceptions.
Oh yeah.
For better or for worse are the way that we do errors. And so,
well, I spent quite a bit of time. The presentation that I gave at the Python conference, which should be up on YouTube by now, but it was about functional error handling. And the one thing that became really clear to me is that the problem with exceptions is they're not part of the type system. And so you don't know.
Unless you go with checked exceptions, but
you will, and nobody who's done checked exceptions has ever declared it a success. And C++ has completely abandoned them in favor of the functional error handling approach, which was something I didn't know, but yeah, that's where they went. So yeah, I think exceptions were a step forward in the whole sequence of figuring out how to handle errors, but certainly not the end point.
Well, I think it's also probably a desperate step, if I may say it without insulting anyone. We have to be honest, right? Handling errors is not an easy thing to do, because you are calling a function, you're expecting a result from the function, great, but something went wrong. How do you receive this other thing? Remember the time of COM API where you get a H result as, ooh, I'm having a really hard time even thinking about it today. So you get H result all over. So what you get in response is an error code, but the data has to be passed by reference and you get it as an out parameter. That's horrible in its own way. So the problem is we've got about 4, if not 5 different ways to handle errors. Every one of them suck. We as humans don't know how to handle this still. And some of us are so eager to declare victory, saying that exception is the way to go. Maybe 400 years from now, there'll be a set of humans sitting and laughing at us, thinking about how idiotic we were in trying to solve this problem, and they have an elegant solution. But I don't know what that is.
I was on the C++ standards committee when the first, well, it wasn't the first proposal of exceptions, but it was when they proposed it for C++. And for all I knew at the time, it sounded like, well, okay, now you have a uniform way to present errors, which we didn't have before. So that was a step forward, and I think people in the future will say they were doing the best with what they had at the time. Sure, if you look at it now and go, oh, you should have a package of return information, and in that can be your error information. That makes so much more sense. But we couldn't see it then.
Yeah, well, and I think that's reasonable.
Man, Go! Oh my God!
Like that was
unexcusable.
I mean, it was.
They knew.
I guess at the time they were like, exception. We don't want to do exceptions, so let's try something new. And then what they got.
We don't want to enforce it though. Yeah, so let's just kind of wave our hands over it and say go is great. But what a yeah, that's a terrible design choice, and they should have known better.
But I guess at the time, maybe
there wasn't that long ago.
Good. Okay, let's just leave it as monads were too scary for them to put into Go.
Right. So or in any form. Yeah. Okay.
So that was a fun tangent.
Now you said you had something you shelved.
Oh yeah.
Yes. Thank you for reminding me that. To go back to what you mentioned. About Victor's experience with deep into the Akka stream libraries and Scala futures. Yeah. One of the points I almost often make is that if you are familiar with multiple languages, the way you see design is very different. With all respect to Victor, I doubt if Victor would have been able to come up with this had he not been so exposed to different ways of thinking in different libraries and different languages. and I think he's got that advantage that a lot of us don't have in terms of that exposure to multiple languages and in-depth design. I often refer to the controversial Sapir-Whorf hypothesis, which says what you think is influenced by the languages, natural languages that you speak. I'm not a language expert. I'm not any expert, but what I can vouch for from my experience is when I used to know one language and the way I used to design to when I started knowing more languages, even in the language that I work with, my design is no longer the same because knowing this other language and how things have been done in there greatly influences the line of thinking. So I think that's really a merit, really he's probably a good case study, an exemplary of what benefit you gain by being truly a polyglot. I think that's useful, I think.
So I have another question about bundles, more I guess in a
gatherers.
Gatherers, sorry. I think bundles.
Maybe they should have called them.
No, gatherers makes sense. I get it. But anyway, so I suppose this is asking, how well does Victor understand his consumers? How much of a challenge do you think this is going to be for people to acquire? Do you think it's maybe less of a challenge than, say, the stuff that we're doing with the effects in Zio? Or
I would say I would definitely. So I just decided to write this in a book, and I do have to.
Yeah, it's the one you're working on now.
The cruising along with Java,
That's
and decided to add this as a part in the book. For
You're
most
like,
part,
here's a brand new API that's going into Java 22. Let's get a chapter for this thing.
Yeah, and I mean, because it goes well with the theme of the book, which is cruising along with Java. Well, there's a new feature in Java. Let's talk about it. But I do have to say that of all the concepts I've presented in the book on the evolution of Java, this one is the most intense. If this was a movie, it does become very intense scenes at this point where you're on the edge of the seat watching the movie. So you start with text blocks and so like nice music playing, pleasant, nice feature, and then you get into records and then pattern matching, which is so sweet. And then you turn into gatherers and you're like, oh my gosh, now there's tension built up.
What dark alley did I just turn down?
Yeah, exactly, right?
At what point were you like, I'm going to need to do a whole book on this?
I think it can take a whole book, in my opinion. There's so much to it. But to answer your question, I would classify this as an advanced topic for sure. The reason I put this as an advanced topic is it requires understanding those four different types I talked about: the stateless, stateful versus sequential parallel, and I call these as escalating levels of complexity. The stateless sequential gatherer is probably the least interesting, but the most easiest one to implement. The stateful parallel is the most difficult to implement. Not in terms of the amount of code you have to write, but the amount of knowledge you have to hold in your head to know how it can do a stateful and parallel together. So, as you know, if you step back to reduce is not really a sequential step. When you run it in a parallel stream, reduce will take partial chunks and work on them, and then combine these partial chunks into more partial results until you get to the final result. Well, that's what you're doing here with the parallel stateful gatherer, because you have the initializer, which is going to create the transformation of data. Then you have a combiner that needs to really combine these partial results, and then you need to implement a finalizer that takes all the last set of partial results and decide to combine them and push them into the downstream. So to not a lot of code, but you need to keep that in your head. And also, as I was writing the examples for this feature, um, there's a temptation to make your lambdas bigger. And if you make your lambdas bigger, you're going to get into a self-inflicted wound. And I decided to fall back on one of the recommendations I've been giving to people is I say lambdas are glue code, 2 lines may be too many. So I don't want anyone to put a curly brace in front of a lambda and put a body of code, whether it's 2 lines or 20 lines. That's not acceptable to me. The reason is when you look at a lambda, you want to know what your intent is. If you're diving into a lambda and reading 20 lines of code, you lost sight of what your functional pipeline is. And so I had to really follow my own advice, dog fooding here. And also, I wrote the code in a messy way and then in an elegant way where I wrote these smaller functions and called those functions from lambdas. And the proof was right in front of me. It went from a code that was really hard for me to understand, my own code, to a code where I was able to reason about much better, knowing these nice separation of this initialization versus combining versus gatherer, which is a recommendation I made in the book as well, is that you following good practices is going to help you better write this code, and your developers, fellow developers, are going to be thankful to you because you didn't create a mess out of this. I think
Likely that code
gatherers,
is more that code is more easily testable. So
oh,
once you've
bingo,
broken it into those small pieces, then you can write
there you
tests
go.
and do
If you give it
TDD for each
function
of those.
names too.
Totally, absolutely. And I think good disciplines, good practices are even more important when we do more complicated things. And at least in my opinion, this may be a walk in the park for Victor, but I would say for me, it's a complex operation. And the more quality things I do, I think I can get through that much better, I think.
So how much support can the IDE give you while you're writing this kind of code?
I'm not sure as much. And I have to say, the reason I say that is I actually don't spend much time on IDs anymore. So it's more of my problem than
Venkat,
IDE problem.
VI guy,
So
right?
I'm
You're
mostly doing VI these days.
yeah.
So
Yeah, I know what you mean. I drag my heels too, but the kinds of feedback, the instantaneous feedback that you can get from an
oh yeah.
IDE that understands your type system is totally, I don't know. It's
You
Oh,
like,
can get that in
agreed.
VI. Yeah.
oh, you can have it.
Yeah.
Yeah. Oh, so
And I think where you're going to gain from this quite a bit is, IDs like IntelliJ IDEA can start synthesizing quite a bit of code for you. Combine that with uh, either IntelliJ IDEA's AI model behind it or a Copilot. I think you're going to have a much better, easy time as long as you can focus on this and verify what it spits out is not nonsense. I think you can leverage the power of those tools. A combination of IDE and AI can maybe help things a lot easier
I
as
wouldn't be
well.
surprised if JetBrains has already added support for this to
no.
IntelliJ IDEA
Well, and
because
if
it's just a new language.
using the type system, then maybe it just
Yeah,
happens
I mean it's just
automatically.
all standard
Yeah.
Java. It's just a
Oh
new
yeah.
API on
Mhm.
Java. Is it marked as experimental in 22? Is
It's a pre-release still,
okay?
yes. And
Yeah.
I
But
believe that's the same way in 23 as well, which is going to be shipping next month, because they try to keep things as pre-release for at least 2 releases. So
yeah,
22, 23, and assuming that goes through really well, I think it would become a release in 24, I would
And
think.
24 is the next, what,
March, yeah.
supported
March.
LTS. Yeah.
long-term support?
That would be 25. So
Oh,
25 would be the long-term support.
sure, fine. Yeah, okay. Uh,
um, wow. Well, thank you for that fun lesson on gatherers, and we'll definitely have to get Victor on to dive in
yes.
deeper.
Uh-huh.
Um, that'd be fun. I know we're almost out of time for you. You gotta to head to the airport as usual. But is there any other topics that we needed to hit on?
I've been excited about the evolution of Java, and I like to call it as a responsible growth of the language. That's what really excites me, honestly. Where you don't have a bunch of yahoos sitting around and saying, "Let's throw things together because people want features and we'll make them happy." I think they're taking a very disciplined approach in evolving the language. I've been keeping an eye on it for quite a while now, and seeing it grow, and every little improvement is something that I really see. I had somebody in one of my classes, and he got really angry, and he said, "This is unfair. I've been programming Java for 20 years. All these young kids can have all these wonderful things. What about me? I never had these when I was young." And I'm like, "Yeah, talk about it, right?" So I've got enough gray hair to, be jealous and angry about it as well. But I'm as happy to see that now in the evolution of the language. So I think that's brilliant, and it's more power to the developers. So I think that's
Exactly.
fantastic.
Always good when we can help developers be more productive, create better programs that have less issues. And
Nice.
it's always a good thing.
Always good.
Are you presenting on anything at your own conference?
I'm giving about 6 talks in the conference.
Oh my God!
But
So
but I decided not to talk about gatherers just
okay.
yet.
I was going to see
I wanted to wait until a little bit later to present about it.
Okay.
We did have a proposal on gatherers, and that was my argument as well. It's great topic, but a little too early for a conference talk, at least for me. So I said, let's wait on it. But having said that, too early doesn't mean a few years. It's a few months, in my opinion.
Yeah.
So I'll be talking about gatherers in conferences in 2025,
Nice.
including the 25 edition of Dev2Next as well. So
Yeah.
I'll definitely talk about
forward
that,
to that.
among
All
other
right.
things.
Keep going. All right.
All right. Well, thank you so much, Venkat. Thanks for joining us, and we'll look forward to seeing you in Denver in 6 weeks.
Yes, and I look forward to both of your talks, and especially I think it's a great opportunity for us to learn about the effect-oriented programming. I think that's going to be huge, and congratulations on your upcoming book on the topic as well.
We still got to
we are
finish
eager
it.
to learn.
Working on
Yes,
it.
well, you got an incentive now to finish it, so
We
do.
do. We have a deadline thanks to you.
Exactly true. Thank you.
So we'll promote that at the conference as well.
Awesome.
Okay.
And thanks, Venkat.
Thank you.